Hello, hello. Alright, so we're taking a look at the standardized test practice. I gave this to you guys as a worksheet. So let's say standardized test practice number 1. These questions do a good job of using all the concepts from the chapter and are a good representation of what you can expect to see on the test. So number 1, 2 satellites are in orbit around a planet. One satellite has an orbital radius of 8.0 times 10 to the 6 meters. Let's call that R1 equals 8.0 times 10 to the 6 meters. R2 is the other satellite has an orbital radius of 2 times 10 to the 7 meters. 2.0 times 10 to the 7th meter. Now the period of 1, it says, is the it's 1 times 10 to the 6 seconds. 1 times 10 to the 6 seconds. And the period of the other, I'm assuming they're not going to give us, because what else would we have to solve for? What is this satellite's period of revolution? So we're looking for the period of revolution of the second satellite here. Ask yourself, what formula are we going to use here? What formula do we have that relates these concepts with the radius of orbit of a satellite and the period of satellite? That's Kepler's third law, which is T1. See, I'm going to put T2 on top. We're solving for T2, so I'm going to put T2 on top. Again, it just makes algebra easier. It doesn't matter which goes on top as long as you keep it consistent. So it's T2 squared over T1 squared equals R2 squared, by squared I mean cubed, over R1 cubed. Hooray. Now I'm just going to multiply both sides by T1 squared, and so that'll give me T2 squared equals T1 squared times R2 cubed over R1 cubed. Now I'm going to take the square root of both sides here to isolate my T2. The period of satellite 2 is, I'm going to write this as a power of the 1/2 because that's how I like to write it. The 1/2 power. Same thing as taking the square root. Now I really just have to plug in. So let's see if I can get this all on the same screen. So my T2 is going to be equal to, and by the way, this will become T1 because it's 1/2 and that 2 will cancel out. And then this will be R2 over R1 to the 3/2 power. If you're confused with that algebra, please talk to me in class, after class, whatever. Okay, so T2 is going to equal this right here. My period for satellite 1 is 1 times 10 to the 6 seconds. 1 times 10 to the 6 seconds. My R2 is 2 times 10 to the 7th meters. 2 times 10 to the 7th meters. My R1 is 8 times 10 to the 6 meters. 8 times 10 to the 6 meters. This is all to the 3/2 power. And again, I'm just plugging in from here. I solved for the period of 2, which is what we're asked for. This is what the other side of the equation looks like. Plugging in my values that we were given in the very beginning. Now I'm going to go ahead and pause and calculate these. Alright, and by the magic of recording, I'm back immediately. So the period of satellite 2 is going to be equal to 3.95 times 10 to the 6. And this is going to be our meters cancel out, and so we're left with seconds. And you'll see that is choice C. Choice C. Alright guys, I'll see you at number 2.